Yeah, away with the slides. Okay, can you read this in the back? Can you put up your hand if you can read it, just so I'm sure? Yeah? Okay, good. Because the more code we can put on the screen, the better, but you want to be able to read it. So it's a little bit scary always doing live coding, so I might make mistakes. If you see me making a mistake, please help me, because it's really hard to see it when you're like on the spot. Okay, so we're going to do sort descriptors in Swift, and originally I wanted to tell everybody something different. I wanted to do a different talk and tell you why you should be using mutating, but I'll just leave that hanging there. I think everybody should use mutating more, but that's a different talk. So now we're going to talk about sort descriptors. And sort descriptors are this API from Foundation, and they're really awesome. So you can use it to sort, for example, an array in a really complex way by combining multiple descriptors. So for example, you could sort by last name first, and then if there's a tie, you can sort then by first name, and then maybe after that by year of birth. So you can sort of combine all these sort descriptors. So let's first look at how to do that in sort of Foundation style with runtime programming, and then we're going to refactor it and do it in Swift functionally, because that's what we're here for. So we're going to create a last name descriptor, and we'll use NSSort descriptor for that. And it has a couple of initializers. So for the key, we'll use a string, last name, ascending true, and then we need a selector. And the selector will be localized case-insensitive compare for two strings. So this compares two strings in a localized way and case-insensitively. Let's see. So I'll put a couple of enters so you can see it a little bit better. So this is how you write a sort descriptor, and they're really cool in a way. The nice thing is that they're very flexible. So you can easily create sort descriptors. They're very powerful. You can pass in different selectors. You can pass in different key paths. And you can even create them at runtime. So let's see how to sort an array. So we can say people, and then we can really only call this on NSArray. So we'll just say as NSArray. And then we can say sorted array using, and then pass in an array of sort descriptors. So we can say last name descriptor. And let's see if it works. If the playground is fast enough, we'll see the output here. So it sorts the array by last name. See if we can make this a bit bigger. And if we want to sort by first name, we can just copy paste this, my favorite style of programming. So first name descriptor, and now we only have to change the key. And we don't have to change anything else. And we can actually say last name, and then if there's a tie, for example, with Johan and Jacob, we can say first name descriptor. So now it first sorts by last name, and if there's a tie, then it uses the first name. And I think this is a really cool API. There are some drawbacks, but it allows you could, for example, build this array at runtime based on the user clicking on some columns. And you don't have to write a lot of code. But there is also some problems with this, because this API is working with key value coding. You might easily make a mistake. So if you write the key path wrong, then you get a runtime crash. Well, there's also the key path. You can write it like this in Swift. So you can say person.firstname, and that'll help you save you from typos. So if you make a typo, at least you get an error there. But still, it's not really perfect because it only works for Objective-C. Key paths only work for Objective-C objects. That's why I had to make person an NS object. And it's not really typed. If I try to sort here by year of birth, the compiler will let me do that, but we'll get a runtime crash. So that's sort of the problems, and we cannot really use this with normal Swift objects. We cannot really use it with structs or enums, and I don't really like runtime programming. So let's try to fix that. I'll delete this line. and maybe change this one back so that at least it's not broken again. Let's see. First name. Okay. So if we look at Swift arrays, there are two methods to sort. So there's sort and sorted. And the one is in place mutating, and the other one gives you a new array. And if they both take one function, and the function that it takes two person values, and then it returns a bool. And it needs to return true if the values are in ascending order already. If they're in descending order, it needs to return false, or if they're equal. And if we want to sort something, then we can just write a function. So we can say P1, P2. And now we can compare. For example, we could say P1 dot last name. And then we can say localized case insensitive compare with P2 dot last name. And then we need to check if it's ordered ascending. Now, there are a couple of problems. So last name is an optional property. And the thing that I'm going to build is not really going to work with optionals. We'll look at that later. So I'll have to change it back to a non-optional. Change this back. And note that sort descriptors work great with optional properties. So let's see if we did everything right. Hopefully this works. What, sorry? Ah, yeah. Thank you. And let's see if we get a sorted list out. So here we get a false. Okay. And now we can print the result. So it sorts. But this is a lot harder to write, I think, and it's not really as descriptive. If we want to sort by first name after this, the code will get really tricky. So what we can do is pull this out into a function. So we can say last name descriptor, and I'll delete these two. So we can say last name descriptor, and then it's a function that takes a person, another person, and returns a bool. So now we can also maybe remove some clutter here. So this is how you can factor that out. And a first name descriptor, probably we need a label here. The first name descriptor is very similar. We can just copy paste it and change it. And here we see the first problem with our current approach. So if I change this one to first name, then I might forget to change the second one. So now it sort of compares first name and last name. So I need to make sure to say first name here as well. And that's one problem. And again, it's a bit clunky to write and not as declarative as the sort descriptors we had before. But we can fix it. So what we can do is sort of move this duplication out into a function. So we can create a function sort descriptor. And it needs to take some kind of property. So something from person to string. So rather than ooh, I'm trying not to move. Let's see. It's always computers, right? Try plugging it out and in again. We had this before also. Sometimes switching the connector might help. Let's see. That's interesting. I cannot do live coding without any code. I should have practiced my jokes. I have really bad jokes.
Do it on the whiteboard.
Let's see. I'll fix it. What's that, sorry? Maybe, yeah. I was standing there. That's good. Let's see, one more try, and then I'm gone. Is it this? Interesting. Help is on the way. Let's see. I think it might be coming back. Thank you. Yes. Okay. We'll move it in a little bit. So I can tell maybe a story in between. I told this once at UIConf already. As some of you might know, I made this presentation app called DexSet. I'm not working on it anymore, so don't ask for too much support. So I made this DexSet app, and when we first launched it, we got some famous people to use it. For example, the creator of Ruby on Rails used DexSet for his presentation at RailsConf, and we launched like 2 weeks ago, and we were watching the live stream from our office, getting very excited that such a famous person is using DexSet, and he walks on stage, and we were watching it, and he walks on stage and he's like, "Can you see my slides?" And of course we were getting really scared because what's going on? Like, can he not see his slides? And he had the problem like for 2 or 3 minutes that his slides were not showing up. We didn't know like what was happening, so he was chatting a little bit, and then his slides were there, and everything went fine. I don't know what happened to this day. If I ever meet him, I'll ask him. But yeah. Anyway, let's get back. So we want to abstract this first name descriptor and this last name descriptor. So I'll try to not interfere with the cable. So we need a property that takes a person and then sort of gets a string value, for example, the first name or the last name. And then it needs to return a sort descriptor. And a sort descriptor, if you remember, it's person to bool. So by this, we can already see that we need to return a function. So let's start with that. So P1, P2. And now inside, we can use this property to compare. So we can take this code and paste it in. And rather than hard coding the first name, we just say property P1. And we say property P2. And let's see if I did everything right. Exactly. Thank you. Then we need to mark the function as escaping. So that's the new Swift thing. So I always use fix all in scope, which fixes everything for you. And now we can write our first name descriptor and our last name descriptor in terms of this function. So we can say sort descriptor, and then say person last name, first name, and likewise over here. So we can say sort descriptor, and then say last name. So this cleans up the code a lot, and I think it's in a way more declarative. But it's very specific to person, and it's a lot of repetition. So we can first start by pulling this out into a type alias. We can call it sort descriptor. So we can say over here, type alias sort descriptor. And then we can use it over here as well. Sort descriptor. Over here. So that's already a little bit nicer. And it's very specific to person objects, and it doesn't really need to be. So we can make this a lot more generic. So we can say, well, actually a sort descriptor for A is a function that takes two A's and compares them and returns if they're ascending or not. And we can do that over here as well. So we can say if we have a string property, then we can create a sort descriptor of A. So this is basically all the same code, just more generic. And then here we finally say person. And over here as well. So that already makes the code a lot more generic. But what if we want to sort by year of birth? So this only works for string properties. So what we can do is pull out this localized case-insensitive compare. And we can first look at the type. So if we say let f equals string localized case-insensitive compare, we can look at the type. See, I'll zoom in a little bit. So we can see that it's a query function which takes two strings and returns a comparison result. So let's put that in. So here we need something that takes a string and another string and returns a comparison result. And we need to give this a name as well. So we can call this compare, maybe. And then instead of calling localized case-insensitive compare, here we say compare, pass in the first property, the second property, and it needs to be escaping as well. And then over here, we can now pass it in. So we can say string.localized case-insensitive compare. So now we need to repeat ourselves a little bit over here. Oh, let's see. Something is wrong. Label and label. So this is a little bit more repetitive, but way more powerful, right? Because now we can use different ways to compare our values. And it's really not specific to strings anymore, so we can also pull that out. So rather than saying A, we can say property. And then we can say property takes an A and produces that property. And here we can say property. Here we can say property. And I really like these kinds of refactorings where you sort of start with your code and then it turns out to be way more generic. And our code still works. So I think that's really cool. And now we can write sort descriptors that compare different types of properties as well. So if we now look back to the NS sort descriptor, we won a lot. We're fully type safe, and we can make this work with structs as well. But if you remember that the NS sort descriptor had this sorted by array of comparators, or array of sort descriptors, that was really cool on NS array. And we cannot really do that. So what we could do is say, well, we extend array or maybe collection or sequence and add a function that takes an array of our sort descriptors. That's one option, but then we need to add two versions, one in-place sort and one normal sort. So this sort of blows up, and I don't think that's the nicest way. What we can do instead is we can combine multiple of these sort descriptors into a single sort descriptor, and that way we don't have to change the array or the sequence API. So that would look something like this. So we can write a function combine, which takes some descriptors. So this is a sort descriptor of A, but then really an array of it. So we'll need an A here as well. And then it combines those into a single sort descriptor. And now the question is, how do we write this? Well, if we look at the type, we know that we have to return a sort descriptor, which is really a function. So we can start with that. So we can say value 1, value 2. And inside now we have our descriptors, and we just need to return a bool. And if you remember, first it tried to sort according to the first descriptor, and then it tried to sort according to the second descriptor. So I'm going to do something very non-functional, but I like it. I'm going to write a for loop. So we can say descriptor in descriptors. So this is the first one. So we can ask this descriptor, are they ascending? So if value 1 and value 2 are ascending, it will return true. So if we write an if condition, so if this holds, then we return true. I'll copy paste it, and we can do it the other way around. So if value 2 and value 1 are ascending, that means that they're descending, then we return false. And then finally, it might be that it's not ascending, it's not descending. That means that they're equal. So in that case, we just continue. So we don't really need to do anything there because we have the for loop. And finally, after the for loop, we need to say something. We need to return some kind of default value. And this way, we can combine multiple sort descriptors into one. So we can say combine, and then an array of sort descriptors. I wonder if that's me. Let's see. Sorry about that. So we can combine multiple sort descriptors over here. So we can say last name descriptor and then first name descriptor. And we'll need a label probably. And then we can look at the type. So x is a function that takes a person, and returns a bool. So now we can sort according to this. So we could say people, let's sort it by, or combine sort descriptors. And let's look and see if we can print the result. Maybe like this. And a little bit bigger. So here we can see that it's first sorted by last name and then by first name. So that's really nice, and we didn't have to do any runtime programming. And there are a couple more things you could do. So it's also easy to write a sort descriptor for anything that is comparable. So if we, for example, want to sort by last year, we can write something like sort descriptor for any A that's comparable, or any property that's comparable. And we can easily use the comparable protocol to automatically generate that sort descriptor for us. And we can write a function that takes an optional property and sorts according to that. So I'll write that one out because it's sort of interesting to write that. So if we want to lift a normal sort descriptor into the domain of optionals, that's why I use lift. We can do that. So we can say if we have a sort descriptor, or if we have a comparison function, we can do it. So if we have something that takes an A, and returns a comparison result. So this is basically the string.localized case insensitive compare. I'll add some parentheses to make Swift happy. We can write a function that takes an optional A, and returns a comparison result. And the way we do this is sort of similar to before. So we need to take a left, and we need to take a right parameter, and close the braces. And in here we can use those. So we can say, for example, switch on left and right. And then we can say, well, if they're both nil, then they're equal. So we return or the same. If one of them is nil, for example, the left one and the right one, well, then they're ascending. Let's see, ordered ascending. And if one of them has a value but the other one is nil, like this, then they're descending. And then finally, if we have two values, so if we say case let sum x, sum y, then we can really use our other comparison operator. So we can say comparison x, y. And this way we can sort of lift comparators into the optional domain. And before it was easier with Swift because there were comparison operators that worked on optionals. They sort of removed that, so you cannot really say optional value is less than another optional value. But using sort of these lift combinators, you can still get that functionality back and be a little bit more explicit about it. There are a lot more things to explore here, but I don't want to take up all the time. One thing I do want to say is that I call this sort descriptor over here, and it's a bit of a hack because, for example, in where we combined multiple sort descriptors, I was calling it multiple times, and really it should be something that returns a comparison result, and it should probably have a different name also. But I think it's still a really powerful example of how you can take this Cocoa API that relies on runtime programming and relies on key value coding and key paths, and completely do it in Swift, completely type safe without any need for that. And of course, the nice thing is that this works on structs. So that's all I have to say, and I'm very happy to take any questions. Thank you. Are there any questions? Oh, we're going to fix that. Yes?
What's that error that's
Sorry?
with your most recent function? There was some error with the optional.
Oh, I think I forgot to write parentheses. That's we can see.
You're missing a dot before the nil.
Oh yeah, and I was writing .nil everywhere. I will quickly fix it while you can see it.
Oh, okay.
So this should be nil, of course.
Magic trick.
I'll just copy paste the finished code. There should definitely be parentheses. You know, I heard there are some Swift 2 lovers in the room, and I need a generic parameter, and we need to mark it as double escaping, at least once. And then finally, unfortunately this is Swift, so we need a default case, which will never happen. Or we could also use ordered same. Let's see. Ah, yeah, this of course is curried. So now it compiles, and now you can say lift string.localized case insensitive compare with a label. And this now works on optionals. Oh, it doesn't. We're functional programmers, right? We like F and G. So this is how you can make that work. Yes?
Could you show again the definition of property?
The definition of property. Yes. Do you mean over here? Line 24? So it just takes an A and returns a property. So it could be, if A is person and property is string, then it takes a person and gets a string value out of it. If A is person and property is year of birth, then it would take the year of birth. Does it make sense?
Yeah, I was just thinking that unfortunately without the introspection you cannot, you have to generate the descriptors by hand. So you have to say dot first name, dot last name, you not go to the key path.
Yeah, I think there are definitely some opportunities there for Swift to improve, but I try to keep I try to not get too emotionally attached to hoping that they would add features like this. So I always, I try to work with what the language has, and this is, I think, one of the easiest ways to do it in the language currently. Maybe they'll improve it. Maybe we'll get first-class lenses, or maybe the property. There's going to change a lot, I think, around properties, but I don't know. Yeah. This is how we have to do it for now. Yes?
Are you aware of any open source components possibly solving this problem already? Have you considered open sourcing? Because this sounds like a nice addition.
Yeah. Yeah, so I should do some promotion. So this is, we were going to discuss this in one of the Swift Talk episodes. I always forget to promote. We're going to discuss this. This is a Swift Talk episode. And then we'll also open source the code around it, but not like open source. We'll just, put it online, which is not really the same as open sourcing code. If anybody wants to take this and make it better and really make a framework out of this, please do. If you want to do that, I like doing that, but I don't really have the time to maintain open source frameworks, or at least I found that I'm really bad at it. So I don't make open source frameworks myself anymore, but I try to give back in other ways.